Hello everyone, welcome back again. So today we are going to continue with the ray diagrams. So we have already started with the object at infinity position in module 6. So today we will see the next object position. So get ready with your book and pen, but make sure that you have watched module 5 wherein I have discussed about the important rules that needs to be followed while drawing the ray diagrams. Okay, once you're thorough with the rules, your ray diagrams will be very easy. Okay, let's continue. So our second object position is beyond C. So here we will be discussing about concave mirror position beyond C. So draw the principal axis, mark P, F and C on your diagram. So as I told you in my previous video that we will be representing our object like this. Okay, our object, a line with upward arrow. This is how we represent our object. Your center of curvature, this is your focus and this is your pole, and you are placing your object beyond C. As heading says, object is beyond C. Now you can apply any two rules here to draw the ray diagram. So let's try. So here I'm using rule 1. So what is rule 1? A ray which is parallel to principal axis. What happens to this ray? After reflection from the mirror. So this is the point where light ray hits. So after hitting the mirror, it reflects and passes through focus. So this arrow shows the reflected ray. It hits the mirror and it passes through focus. This is rule 1. Now we have to use one more rule to get our image. Why we are using two rules? Because we will get our image only when reflected rays meet. So reflected rays should meet. Then only we will get our image. Now we have one rule we have applied here. Now we are applying one more rule. So I am applying rule 2, that is passing through the focus. See here the blue shows it is passing through the focus. Then again it hits the mirror. Then what happens? After reflection it becomes parallel. This is rule 2. Now we can see the reflected rays are meeting at this point. This is the meeting point of our reflected rays. So you will get your image here. So this is your object, this is the object, and this is your image. So the picture of this object will be obtained at this point between C and F. This is the point where you are getting your image. Now let's see what are the important characteristics of the image formed by this object. Image characteristics. So here, what is the nature of the image? Nature of the image is real and inverted. Why it is real and inverted? Because your reflected rays are meeting in front of the mirror. So your image is formed in front of the mirror. So wherever you see the reflected rays meeting in front of the mirror, you will get a real and inverted image. Now whatever the size of the image, it says diminished. Diminished means small. So you are comparing the image size with your object. So when you compare the object and image, you can see that your image is smaller than your object. So we call it as diminished. Now position of the image. Where you are getting the image? Yes, you are getting between C and F. So these are the important characteristics. So you can apply any two rules to get the diagram. Okay, so I have applied rule 1 and rule 2. Now next object position is we are moving the object closer to the mirror. So it was beyond C. Now I am moving the object closer to the mirror. So next position is at C. Again you have to draw the mirror, draw the principal axis, label all the points. You have to label C, F and P. And don't forget the distance between the points must be equal. From F to P and F to C, the distance must be equal. If you are taking this as 1 centimeter, take this also 1 centimeter. So equal measurements. Now I am placing my object at C. So this is my object position. So let's see. So I am applying rule 1 again. So what happens? It hit the mirror. What happens after reflection? Parallel rays after reflection will pass through focus. Now you can see it is passing through the focus. Now I am applying rule 2, which is incident ray passing through the focus. After reflection it becomes parallel to the principal axis. Now where are they meeting? They are meeting at this point. This is the meeting point of the reflected rays. So you will get the image at C. Since this is the meeting point, you will get the image at this point. This is the meeting point. Now tell me, what are the characteristics? Whenever I say image characteristics, you should write the nature, size and position. Yes, since the image is formed in front of the mirror, it is real and inverted. Now when you compare the image size with the object size, both are same. So image size is same. Now what is the position? Where are you getting the image? You are getting the image at C. This is the point at C. This is the point where you are getting your image. Now next position is, we are again moving our object closer to the mirror. So next position is between C and F. Again draw the mirror, mark the principal axis, pole F and C. Okay, your center of curvature, focal point and the pole. Now the object is placed between C and F. This is your object. Now again you can apply any two rules. So here I am applying rule 1, which is parallel to principal axis. So what happens? After reflection it will pass through F. Very good. Now rule 2 I am applying, yes, which is passing through the focus. Then it hits the mirror. After reflection it becomes parallel. Yes. Now compare this. Yeah, now see where are the reflected rays are meeting. Reflected rays are meeting at this point. This is the point of intersection of the reflected rays. Now you will get your image at this point. So where are you getting the image? Yes, you're getting beyond C. Yes, object was beyond C. When you placed your object beyond C, where did you get your image? Between C and F. Now when your object is between C and F, where are you getting your image? Beyond C. So just compare. You can compare and learn. It is easy. Beyond C, you are getting image between C and F. Between C and F, you will get your image beyond C. Now let's write the image characteristics. Yeah, what is the nature? As usual, real and inverted, because the reflected rays are meeting in front of the mirror. Now compare the size of the image and the object. You can see the image size is bigger than the object size. So we use the scientific term enlarged, or you can write magnified. Now position of the image. Image is formed beyond C. That's great. Now again we are moving the object closer to the mirror. Now next position is at F. Now our object is at F. Again draw the mirror, label the points P, F and C, and I'm placing my object at F. So here I am applying rule 1, that is parallel to principal axis. Then what happens to the ray after reflection? It passes through F. See, don't confuse. It should pass through F. You cannot draw like this. Okay, when you draw like this, it is wrong. Why? Because our rule says when it is parallel to principal axis, it should pass through F. Your F is here, so it should pass through this point. So keep that in mind when you are drawing the diagram. Yes. Now here I cannot apply rule 2 because my object is at F. So rule 2 means the ray should pass through F. So that is not possible in this case. So I am using the next rule, that is hitting the pole Yes, when incident ray hits the pole, it gets reflected obliquely by making same angle of incidence and angle of reflection same. So here I have used rule 1 and rule 4. You can use rule 3 also. Rule 3 also works here. So here you can see the rays are going like this, yeah, which means that the image will be formed at infinity. You will get your image at infinite, very far. Compared to this object position, your image will be very far. Again, another trick here. When object was at infinity, when your object was at infinity, where did you get your image? At focus. Now your object is at F. So where are you getting your at F? So where are you getting your image? Yes, image is formed at infinity. So again, opposite. When object at infinity, image at focus. When object at focus, your image is at infinity. So easy to learn. Just compare and learn. Let's see the characteristics. So again, real and inverted, because the rays will meet in front of the mirror, and it is highly enlarged. When image is formed at focus, it was highly diminished. Now when image is formed at infinity, it is highly enlarged. Or you can use the term highly magnified. Okay, highly magnified. Now where will you get the image? At infinity. Now let's see some of the application of this object position. When your object is placed at F, where are we using in our real life? Yes, in torchlight. We use in torchlight, and we use in headlights, car headlights, okay, or vehicle headlights. So here the bulb is, this is the bulb. The bulb is fixed at the focus, and this part of the mirror is the concave mirror. So when light from the mirror hit the reflecting surface, it creates the parallel beams so that you can see large distances. Vehicles, the headlight of the vehicles. Here bulb is also fixed at the focal point, and this is the concave part of the mirror. So light will reach at the far point, so people can see large distances. So these are the two applications of object position at F for concave mirror. Now let's move on. Now object position is between F and P. So label the points C, F and P. So I'm placing our object. This is our object. So I'm placing between F and P. Now again I'm using rule 1, parallel to principal axis. Now careful when you are drawing the reflected ray, it should pass through your F. Okay, this is my focus. So the reflected ray is passing through F. Now I have used rule 4 again. So incident ray, then it reflects obliquely by making the same angle. So here you can see your reflected rays are diverging. So we know that diverging rays never meet. So what we have to do? We will extend this reflected ray. Then we can see that the reflected rays are diverging from this point. From this point they are going away, spreading out. From this point, this ray is also spreading out. So you will get your image at this point. So this image, since it is formed behind the mirror, it is formed behind the mirror. You are getting your image behind the mirror. Now let's see the characteristics. So nature of the image is virtual and erect. Why it is virtual and erect? Because you are getting your image behind the mirror. If reflected rays are meeting in front of the mirror, you will get real image. If reflected rays are meeting behind the mirror, you will get virtual image. Okay. Now size. Compare the size of the image with the object. It is magnified or enlarged. Magnified. Now what is the position of the image? Image is behind the mirror. So this is the only position where concave mirror forms virtual and erect image. So remember, between F and P, the image formed is virtual and erect. Rest all positions, it forms real and inverted. These are some of the important applications of concave mirror for this particular object position, that is between F and P. So we know that when the object is placed between F and P, the image formed is virtual and erect. And also you will get a magnified image. See here in this makeup mirror, you can see the enlarged image of your eye and it is upright. Same for the dentist mirror, you can see the enlarged image. The doctors can see the enlarged image of the teeth using the dental mirror. And it is virtual and erect. That is the benefit of using concave mirror at this position. So here you have to hold the mirror very close in the sense it is between F and P. And if you try to move the mirror far from your face, you will get real and inverted. But if you hold it very close to your face, you will get virtual and erect and it is magnified. So this principle is applied for makeup mirrors and dentist mirrors. So that's it for today. So if you have any doubts or any questions, you can post it on the comment. I will be replying to your comments. So thank you. Have a nice day. We will see you again with another interesting module in the next video.